Good afternoon, everyone. Today we are going to solve NCERT exercise 7.8. This exercise based on the definite integral concept that we discussed earlier, including the formulas, theorem like the first and second fundamental theorem of calculus. So we will solve the question step by step. Okay. So the first question is evaluate the definite integral from -1 to 1 x plus 1 dx. So to find the value of definite integral, we already know at first we have to find the indefinite integral and then apply the second fundamental theorem. So at first you try. So the answer is 2. We know that whenever we calculate the definite integral, the value is numerical value. And in case of indefinite integral, the value is again a function. Okay. Or indefinite integral is related to a area function, that is when we calculate the definite integral from -1 to 1 x plus 1 dx, it gives the area of the curve x plus 1 from lower limit -1 to 1, that it is the area of the region x is equal to -1 line, then x equal to 1 line and the horizontal x-axis. Okay. So here we need to evaluate the definite integral -1 to 1 x plus 1 dx. Let the integral be I is equal to -1 to 1 x plus 1 dx. So at first we have to find the antiderivative or indefinite integral. What is the difference between indefinite integral or antiderivative? There is only one difference, that is antiderivative but without constant of integration. Okay. So of the function x plus 1, when we integrate, we get integration of x dx plus integration of 1 dx. And by using the standard formula of integration, that is integration of xn is xn plus 1 by n plus 1 plus c, we get x plus 1 by 1 plus 1 plus x, that is x square by 2 plus x. So this is our indefinite integral, that is value of antiderivative. So first step is complete. In second step, we apply the second fundamental theorem of calculus, which state that if capital Fx is an antiderivative of fx, then the value of definite integral from lower limit a to upper limit b fx dx is equal to capital Fb minus capital Fa. Okay. So now in this case, fx is x plus 1, lower limit is a equal to -1 and upper limit is b is equal to 1. So to evaluate fx at upper limit, we just put in place of x 1, and for lower limit x is equal to -1, and then subtract to get the result of definite integral. So I is equal to f1 minus f minus 1. So at first we find value of f at 1. So just substitute x is equal to 1 2fx. So we get 3 by 2, and the evaluate f at -1, we get -1 by 2. So when we subtract, we get the value of definite integral, that is 3 by 2 minus into -1 by 2. So I is equal to 4 by 2, that is 2. Therefore, the value of definite integral is 2. So, to calculate a definite integral, in first step, we have to find the indefinite integral, that is antiderivative. And when we calculate the antiderivative, we just need to subtract antiderivative at upper limit minus the value of antiderivative at lower limit. Then we get the value of definite integral. Okay. So question number 2 is, evaluate the definite integral from 2 to 3 1 by x dx. So try. So answer is log 3 by 2. Let's see step by step solution. So we need to evaluate the definite integral from 2 to 3 1 by x dx. So here fx is equal to 1 by x, lower limit a is equal to 2, and upper limit b is equal to 3. So let the integral be I, that is I is equal to integral 2 to 3 1 by x dx. So at first we have to calculate the antiderivative. So when we calculate antiderivative, that is integration of 1 by x dx is equal to log x. It is a standard integral formula. So fx is equal to, capital Fx is equal to log x. That is a value of antiderivative. Step 1 is completed. Now we apply the second fundamental theorem of calculus, which states that capital Fx is an antiderivative of fx, then definite integral a to b fx dx is just capital Fb minus Fa. So in this case, fx is 1 by x, a is 2, and b is 3, and antiderivative is log x. So just calculate log x value at 3 and at 2 and subtract. Then subtract. So the value of definite integral is f3 is log 3, f2 is log 2. Now subtract f2 from f3. We get I is equal to log 3 minus log 2. So using the logarithmic property, log a minus log b is log a by b. So I is equal to log 3 by 2. Therefore, the definite integral evaluate to log 3 by 2. Okay, so question number 3 is, evaluate the definite integral from 1 to 2 4x cube minus 5x square plus 6x plus 9 dx. So now I'll give you some time to try this question. So answer is 64 by 3. So to evaluate the definite integral from 1 to 2, 4x cube minus 5x square plus 6x plus 9, at first we have to calculate antiderivative of that function. So we apply the power rule of integration. Power rule for integration, that is integration of xn is x to the power n plus 1 by n plus 1 plus constant of integration. So integration of 4x cube minus 5x square plus 6x plus 9 dx, the integration is separated to individual terms. We get the constant is comes out of the sign of integration. We get 4, then integration of x cube minus 5 integration of x square plus 6 integration of x plus 9 integration of dx. So by using the power rule of integration, we get 4 into x to the power 4 by 4 minus 5 into x cube by 3 plus 6 into x square by 2 plus 9x. So the value of antiderivative is x to the power 4 minus 5x cube by 3 plus 3x square plus 9x. Now we apply the second fundamental theorem of calculus. So the value of definite integral fx dx is antiderivative at b minus antiderivative value at a. So here the lower limit is 1 and upper limit is 2, that is a is equal to 1 and b is equal to 2. So the value of definite integral is I is equal to f2 minus f1. So now we evaluate the value of f2 and f1. So the value of f2 is 2 to the power 4 minus 5 to the power cube by 3 plus 3 into 2 square plus 9 into 2. So when we simplify, we get, just do a calculation, simple calculation, we get 98 by 3. Now evaluate f1. At first substitute x is equal to 1 at the value of antiderivative. We get 1 to the power 4 minus 5 into 1 to the power cube by 3 plus 3 into 1 square plus 9 into 1. So we get 1 minus 5 into 1 by 3 plus 3 into 1 plus 9. So just simplify. We get 34 by 3. So finally subtract f1 from f2. We get I is equal to 64 by 3. And that is the value of definite integral. Okay. So question number 4 is evaluate the definite integral from 0 to pi by 4 sine 2x dx. Try this. So the answer is 1 by 2. So to evaluate the definite integral from 0 to pi by 4 sine 2x, we know at first we have to calculate the value of antiderivative of sine 2x. So we use a simple substitution, or we can use a standard integral formula, and that is standard integral formula of sine ax is integration of sine ax dx is minus cos ax by a plus c. We can also use the substitution method. Just substitute 2x is equal to t, differentiate, and we get the same formula, that is minus cos x by a plus c. So applying this, we get the value of antiderivative is that minus cos 2x by 2. So fx is equal to minus cos 2x by 2. Now we apply the second fundamental theorem of calculus, that is value of definite integral from a to b fx dx is capital Fb minus capital Fa. Here the value of a is 0 and b is equal to pi by 4. So we have to calculate the value of antiderivative at a is equal to 0 and b is equal to pi by 4, and then subtract it. So the value of definite integral become f pi by 4 minus f0. So at first we calculate f at pi by 4. So f at pi by 4 is equal to minus cos 2x, that is 2 into pi by 4 by 2. So it become minus cos pi by 2 by 2. And we know the value of cos pi by 2 is 0. So the value of f pi by 4 is 0 minus 0 by 2, that is 0. So now we evaluate f at 0. So it become minus cos 2 into 0 by 2, that is minus cos 0 by 2, and the value of cos 0 is 1. So f0 is minus 1 by 2. Finally subtract f0 from f pi by 4. So I is equal to 0 minus 1 by 2. So the value of definite integral is 1 by 2. Okay. So now evaluate the definite integral from 0 to pi by 2 cos 2x dx. Same as previous question. So you try. Answer is 0. So let's evaluate the definite integral from 0 to pi by 2 cos 2x dx. So at first we find the value of antiderivative. So antiderivative cos 2x, that is integration of cos 2x. Now we can use the simple substitution method, or we can recall the standard integral form. That is integration of cos ax dx is sin ax by a plus c, and integration of cos 2x is sin 2x by 2. That is the value of antiderivative. So now we apply the second fundamental theorem of calculus, which states that for a definite integral a to b fx dx is equal to the value of antiderivative at upper limit minus value of antiderivative at lower limit. Here the value of a is 0 and b is equal to pi by 2. So the definite integral is equal to f pi by 2 minus f at 0. So at first let's find f at pi by 2. It becomes sine at 2 into pi by 2 by 2, that is sine pi by 2. Since sine pi is equal to 0, so f pi by 2 is equal to 0 by 2, that is 0. Next evaluate f0. So sine 2 into 0 by 2, that is sine 0 by 2. So sine 0 is equal to 0. So f0 is also 0. So finally subtract f0 from f at pi by 2, we get the value of definite integral, that is 0. Okay. So the next question is, evaluate the definite integral from 4 to 5 ex dx. Okay, just try. Answer is e the power 4 into e minus 1. Let's see step by step solution. Consider it as I. So let's evaluate the definite integral from 4 to 5 ex dx. Here lower limit is 4 and upper limit is 5. So at first we find the value of antiderivative of ex. So the standard formula for ex is integration of ex dx is ex. Let capital Fx, so fx is equal to ex. Now we apply the second fundamental theorem to calculate definite integral. So just evaluate the value of antiderivative at point 4 and at point 5 we get I is equal to f at 5 minus f at 4. So when we calculate f at 5, it is e the power 5 and f4 is e the power 4. So finally subtract f4 from f5, we get I is equal to e the power 5 minus e the power 4. So we can factor out e the power 4 from the expression. So I is equal to e the power 4 into e the power into e minus 1. So the value of definite integral is e the power 4 into e minus 1. Next question is, evaluate the definite integral from 0 to pi by 4 10x dx. So I will give you some time. Try this question. At first, find the antiderivative, apply second fundamental theorem and find the value of definite integral. The answer is 1 by 2 log 2. So let's evaluate the definite integral from 0 to pi by 4 10x dx. So at first we find the value of antiderivative of 10x and we know the integration of 10x is minus log cos x plus c. It can be also be expressed as log sec x plus c. So capital Fx is minus log cos x. So now we apply the second fundamental theorem, which state that definite integral is equal to antiderivative at lower upper limit minus antiderivative at lower limit. Here upper limit is pi by 4 and lower limit is 0. So I is equal to f at pi by 4 minus f at 0. So at first we evaluate f at pi by 4. So at pi by 4 it is minus log cos x. So cos pi by 4, and the value of cos pi by 4 is 1 by root 2. So f pi by 4 is equal to minus log 1 by root 2 is equal to minus log 1 by root 2. So next evaluate f at 0. So it is minus log cos 0. So cos 0 is equal to 1. And so f0 is minus log 1 and the value of log 1 is 0. So f0 is 0. So now we have value of f pi by 4 and f at 0. So finally subtract f0 from f pi by 4. We get I is equal to minus log 1 by root 2 minus 0. So I is equal to minus log 1 by root 2. Now using the logarithmic property, log a to the power b is b log a and log 1 by x is minus log x. So 1 by root 2 can be written as 2 to the power minus 1 by 2. So log minus log, first apply second property, so it becomes minus log to the power minus 1 by 2. So minus into minus 1 by 2 log 2, it becomes 1 by 2 log 2. Now if we use integration of 10x as log sec x, so fx is log sec x. So f pi by 4, that is log sec pi by 4, that is log root 2. So log root 2 is equal to log 2 to the power 1 by 2. So that is 1 by 2 log 2. And f0, that is log sec 0. So that is log 1. So 0. So we get the same value. That is 1 by 2 log 2. So the value of definite integral is 1 by 2 log 2. Question number 8 is evaluate the definite integral from pi by 6 to pi by 4 cosec x dx. If you know the integration of cosec x dx, you can easily calculate. Okay, try. The answer is log root 2 minus 1 by 2 minus root 3. So to evaluate the definite integral, I is equal to from pi by 6, that is lower limit, to pi by 4, that is upper limit, cosec x dx. So at first calculate antiderivative of cosec x. So by using the standard integral formula, that is integration of cosec x dx is log cosec x minus cot x plus c. And it can also be expressed as log 10x by 2 plus c. So you can use any of these two to find the value of definite integral. So value of antiderivative is log cos x minus cot x. Just apply the second fundamental theorem of calculus. Calculate the value of antiderivative at pi by 6 and pi by 4 and subtract fb minus fa. We get the value of definite integral. So when we evaluate f at pi by 4, it is log cosec pi by 4 minus cot pi by 4. That is, we know by trigonometric values, cosec pi by 4 is root 2 and cot pi by 4 is 1. So f pi by 4 is equal to log root 2 minus 1. Next we will evaluate f at pi by 6. So it log cosec pi by 6 minus cot pi by 6. Cosec pi by 6 is 2 and cot pi by 6 is root 3. So f at pi by 6 is equal to log 2 minus root 3. So finally subtract f pi by 6 from f pi by 4. We get I is equal to log root 2 minus 1 minus log 2 minus root 3. So using the logarithmic property, log a minus log b is log a by b. So when we apply this logarithmic property, the value of definite integral is log root 2 minus 1, that is a, by b, that is 2 minus root 3. So we can further simplify this solution by expression by rationalizing the denominator. Multiply the numerator by the conjugate of the denominator, that is rationalization of denominator. So the denominator is 2 plus root 3. Conjugate of denominator is 2 plus root 3. So multiply and divide by 2 plus root 3. We get root 2 minus 1 into 2 plus root 3 by 2 square minus root 3 whole square. So we get, when we multiply 2 root 2 plus root 6 minus 2 minus root 3 by 4 minus 3. Just simplify it. I is equal to log 2 root 2 plus root 6 minus 2 minus root 3. So either log root 2 minus 1 by 2 minus root 3 or log 2 root 2 plus root 6 minus 2 minus root 3 are the solution of definite integral. Now the next question is, evaluate the definite integral from 0 to 1 dx by root under 1 minus x square. Okay, so at first find the value of indefinite integral dx by root under 1 minus x square, then apply the fundamental theorem of integral calculus and calculate the value of definite integral. Okay, try. So answer is pi by 2. Let's solve. Now we have to evaluate the definite integral. I is equal to 0 to 1 dx by root under 1 minus x square. So at first we find the antiderivative of 1 by root under 1 minus x square. The standard integral formula for 1 by root under a square minus x square is, if you remember, it is sine inverse x by a plus c. So we use this formula directly and find the value of antiderivative. We get, in this case, a is equal to 1. So the value of antiderivative is sine inverse x. Now we apply the second fundamental theorem of calculus. So for that we calculate antiderivative at value at upper limit, that is 1, then subtract it f capital antiderivative value at lower limit, that is f0. So I is equal to f1 minus f0. So capital Fi is sine inverse 1. We need to find the angle whose sine is 1, that is pi by 2 radians. So the value of sine inverse 1 is pi by 2. Okay, we can substitute in place of 1, that is sine pi by 2, and sine inverse sine pi by 2 is pi by 2. To evaluate f0 is sine inverse 0. We need to find the angle whose sine is 0. This is 0 radians. So sine inverse 0 is 0. Finally subtract f0 from f1. We get the value of definite integral, that is pi by 2. Okay. So the question number 10 is, evaluate the definite integral 0 to 1 dx by 1 plus x square. So at first we calculate the integral of 1 by 1 plus x square, and that is a standard form. So recall the standard form, try to write the formula, and then calculate the definite integral. So the answer is pi by 4. At first we find the antiderivative of 1 by 1 plus x square. The standard integral formula for 1 by a square plus x square. Here the value of a is 1, and we know the integration of dx by a square plus x square is 1 by a tan inverse x by a plus c. So the antiderivative of 1 by 1 plus x square is integration of dx by 1 plus x square is equal to 1 by a, that is 1, into tan inverse x by a, that is x. So tan inverse x is the value of antiderivative. Now we apply the second fundamental theorem of calculus. So calculate the value of antiderivative at upper limit, then minus the value of antiderivative at lower limit, that is 0. So f1 minus f0. So at first evaluate f at 1. So f at 1 is tan inverse 1. So we need to find the angle whose tangent is 1, and that is pi by 4. So tan inverse 1 is pi by 4. Similarly, when we calculate f0, we need to find the angle whose tangent is 0, and that is 0 radians. So the value of f0 is 0. and then subtract f0 from f1, we get the value of definite integral, that is pi by 4. Now, the next question is evaluate the definite integral from 2 to 3. So here upper limit is 3, lower limit is 2 dx by x square minus 1. It is also in standard form. So at first find the antiderivative by using that standard form. So answer is 1 by 2 into log 3 by 2. So at first evaluate the definite integral. I is equal to integration from 2 to 3 dx by x square minus 1. So at first we find the value of antiderivative of 1 by x square minus 1. So now we use partial fractional decomposition, or using the standard integral formula we can find the antiderivative. Okay. Using partial fractional decomposition, we can write 1 by x square minus 1 as 1 by x minus 1 into x plus 1. And here both are linear factor. So the form of partial fractional decomposition is a by x minus 1 plus b by x plus 1. So now we have to find the value of a and b. And for that, multiply x minus 1 into x plus 1 both sides. We get 1 is equal to a into x plus 1 plus b into x minus 1. Now to get the value of a, just substitute x is equal to its roots of denominator, and that is 1 and minus 1. So when we set x is equal to 1, the term involving b is 0, and we get an equation with only one variable, that is a, and that is 1 is equal to 2a. So the value of a is 1 by 2. To find b, just set x is equal to minus 1. So 1 is equal to a into minus 1 plus 1 plus b, that is minus 1 minus 1. So we get an equation involving only b, and that is minus 2b is equal to 1. So the value of b is minus 1 by 2. So substitute back into the partial fractional decomposition. We get 1 by 2 into x minus 1 minus x plus 1. Now integrate this expression. We get, by using the standard integral formula, 1 by u du, that is log u plus c. So integration of 1 by x minus 1 is log x minus 1, and integration of 1 by x plus 1 is log x plus 1. Now using the logarithmic property, that is log a minus log b is equal to log a by b. So the solution become 1 by 2 log mod x minus 1 by x plus 1. So the value of antiderivative is 1 by 2 log mod x minus 1 by x plus 1. So now we apply the second fundamental theorem of calculus, which states that the value of definite integral from a to b fx dx is capital Fb minus capital Fa. Here the value of a, that is lower limit, is 2 and upper limit is 3. So now we find the value of f3 and f2. So my definite integral become I is equal to capital F3 minus capital F2. So first evaluate the value of antiderivative at a point 3. So just put x is equal to 3, we get 1 by 2 log mod 3 minus 1 by 3 plus 1, that is 1 by 2 log 2 by 4. So it become 1 by 2 log 1 by 2. Next, we find the value of capital F2. So F2 is equal to 1 by 2 log mod 2 minus 1 by 2 plus 1. So it become 1 by 2 log 1 by 3. So to find the value of definite integral, finally we subtract F2 from F3. So I is equal to 1 by 2 log 1 by 2 minus 1 by 2 log 1 by 3. So factor out 1 by 2. We get I is equal to 1 by 2 log 1 by 2 minus log 1 by 3. So using the logarithmic property, that is log a minus log b equal to log a by b, we get I is equal to 1 by 2 log 1 by 2 by 1 by 3. And when we simplify, we get 1 by 2 log 1 by 2 into 3. So it become 1 by 2 log 3 by 2. So the value of definite integral is 1 by 2 log 3 by 2. Now the question number 12 is evaluate the definite integral from 0 to pi by 2 cos square x dx. So how we can find the indifferent antiderivative of cos square x dx? Just think and try to solve. So the answer is pi by 4. So let's evaluate the definite integral I is equal to from 0 to pi by 2 cos square x dx. So at first we find the value of antiderivative of cos square x. Now we cannot directly integrate cos square x using basic power rules instead. Now we apply the trigonometric identity for cos square x such that it converted to 1 plus cos 2x by 2, and we know the integration of cos 2x 1 by 2. So now we can find the antiderivative of cos square x using the trigonometric identity. Cos square x is equal to 1 plus cos 2x by 2. So substitute this into the integral. We get integration of cos square x is equal to integration 1 plus cos 2x by 2 dx. So 1 by 2 integration 1 plus cos 2x dx. We get 1 by 2, then integration of 1 dx plus integration of cos 2 dx. So we know that integration of 1 dx is x and integration of cos x dx is sin x by a. Just apply the formula. We get 1 by 2 x plus sin 2x by 2. Here the value of a is 2. So the value of antiderivative is x by 2 plus sin 2x by 4. First step is complete. Now we apply the second fundamental theorem of calculus, which states that for a definite integral from a to b fx dx, the value is the value of antiderivative at upper limit, that is pi by 2, minus value of antiderivative at lower limit, that is 0. So I become f pi by 2 minus f0. So now we find the value of f at pi by 2. So it become pi by 2 by 2 plus sine into 2 into pi by 2 by 4. So it become pi by 4 plus sine pi by 4. Since sine pi is 0, so the value of f pi by 2 is pi by 4 plus 0 by 4 is equal to pi by 4. Next evaluate f at 0. So f0 is equal to 0 by 2 plus sine 2 into 0 by 4. It becomes 0 plus sine 0 by 4. Now the value of sine 0 is 0. So f0 is 0. Finally subtract f0 from f pi by 2 to get the value of definite integral. So the value of definite integral is pi by 4 minus 0. Therefore, definite integral is pi by 4. Okay. So the next question is evaluate the definite integral from 2 to 3 x dx by x square plus 1. So you have some time, try to solve this question. So evaluate the integral x dx x square plus 1 from 2 to 3. The answer is 1 by 2 log 2. So at first we have to find the value of antiderivative. So we can use the substitution method to find the value of antiderivative. So just take u is equal to x square plus 1. We take x square plus 1 as u because when we differentiate it with respect to x, we get 2x, that is constant multiple of numerator. So we can replace numerator with du, that is du is equal to 2x dx. So x dx can be written as 1 by 2 du. So integration of x by x square plus 1 dx is integration of 1 by u into 1 by 2 du, that is 1 by 2 integration of 1 by u du, that is standard integral formula, that is log u. So substitute back u is equal to x square plus 1. The antiderivative is 1 by 2 log x square plus 1. Since x square plus 1 is always positive, we can write it as 1 by 2 log x square plus 1. Because log is not defined for negative, so we just take absolute sign. So let fx is equal to 1 by 2 log x square plus 1. Now we apply second fundamental theorem of calculus. Calculate fb and fa and subtract. Here a is 2 and b is equal to 3. So the value of definite integral is f3 minus f2. So first evaluate f3. Just put x is equal to 3. We get 1 by 2 log 10 and f2 is 1 by 2 log 5. Finally subtract, we get 1 by 2 log 10 minus log 5. Apply the property of logarithmic, that is log a minus log b is log a by b. We get I is equal to 1 by 2 log 10 by 5, that is 1 by 2 log 2. And that is the value of definite integral, that is 1 by 2 log 2. Okay, so that's all for today. Okay, thank you.